Hi, hello, namaskara. Welcome to Tech Girl Kannada YouTube. Heaps and heap sort. Complete binary tree. If the maximum level of binary tree is I and the number of nodes at level I is equal to 2 power I, that is number of nodes, that is complete binary tree. Almost complete binary tree or nearly complete binary tree, a binary tree of level I is called ACBT. If and only if the following two conditions satisfied. If level of tree is I, it should have 2 power I nodes in the level. If 2 power I nodes are not present in level I, in I minus 1th level, the number of nodes should be at least 2 power I minus 1, and in level I, all nodes should be filled from left to right manner. This is an ACBT. This is not an ACBT. This is an ACBT. This is not an ACBT. Heap. A heap is a complete binary tree or ACBT such that the key at the each node is greater than or equal to the key of its children. Yes, heap is a complete binary tree such that the key at each node is greater than or equal to the leaf of its children, key of its children. Ascending heap, that is min heap. Descending heap, that is max heap. Ascending heap, an item in any given nodes is less than or equal to the left child and the right child. A root node contains least element and the elements in the path from the root to the leaf will be ascending order. If you want the descending heap, you will have any item at the given node is greater than or equal to the left or right child. Root nodes contains highest element, that is max heap. Since heap is CBT or ACBT, the nodes can be numbered from root to one level at the time. In each level, the nodes are numbered sequentially from left to right. Not heaps because all leaves are at the lowest level are not inserted from left to right fashion. Not heap because it is either descending heap or ascending heap. 50 40. It is neither descending. Yes. Then how to find the position of the parent of given child's position? It will be if the given child node C child position of the parent node say that be obtained by C minus 1 by 2. How to find the position of the child of given parent position? A given node P of parent, position of left child is 2p plus 1, position of right child is 2p plus 2. In ascending heap, the item in each parent is less than or equal to the item in the left child and the right child. The relation between the parent node and two children. Positioning of the left child is 2p plus 1, right child is 2p plus 2. A of p is less than or equal to the minimum of a of 2p plus 1 minimum comma a of 2p plus 2 for p equals to 0 1 to n by 2 minus 1. In the descending heap, the item in which the parent is greater than or equal to items in the left and right child, the relation between the parent node and the two children in descending heap is A of EP is greater than or equal to max of A of P 2P plus 1 comma A of 2P plus 2. If right child does not exist, then A of P is greater than or equal to 2P plus 1. Heaps are represented using arrays and not using linked list. A tree is represented as an array but not as a linked list. Heap tree as well. Then now create a heap, bottom up heap construction. Create a heap for the elements 535 in order, not either ascending nor descending. The order how they have given, we have to consider in the same way. Create a heap of elements. Since there are 15 elements, we have to create the tree which is having the 15 nodes in it. We have created. Now, if we see the elements 5, 35, 25 and all, we are just having it is neither ascending nor descending. Consider the last non-leaf node, that is 55. Compare 55 with its child, that is 15. And the subtree satisfies the heap condition and no change is required. So consider the next non-leaf node, that is 20, and compare 20 with 30. Change is required. So swap that. Compare 20 with 10 and 30. 20 is greater than 10 but less than 30. Subtree is not in heap. To match that, swap 20 and 30. Then we can have this as 45, 45, 50 as well. We have to change 50 position to that place first. Then again, after seeing that, we'll turn 35 there and we'll be changing it. After that, 45 goes up, 50 goes upper than 45, then everything is now satisfied. So then algorithm for this bottom up is to create a heap using the bottom up, that is the max heap. Then analysis of this max heap will be like this. Analysis of the creating a heap using bottom up. Observe the number of comparisons required to move on item I, then h minus 1, then h minus I. This will be like design. Let us assume that it will be of this manner, and then we are comparing it. For this, we have first comparison, find the largest child. Second comparison, determine whether parent should be exchanged with the child node or not. Then total number of comparisons required to move a single node from level I to leaf level in the worst case is given by 2 of h minus I. Number of nodes at level I is 2 power I. The total number of comparisons required to move all these nodes from level I to leaf level is given by 2 of h minus I into 2 power I. Starting from last non-leaf nodes at level I, which is at the height of h minus 1, move backwards till we get the root node which is at level 0. So the total number of key comparisons from the level h minus 1 to level 0. That is like this 2 power h. Here if we consider f of n is 2h minus I into 2 power I, h minus I into 2 power I, h into 2 power I into 2 power I, then 2 power I into 2 power I. We will get one value. Then for this, after comparing everything, we will get to create a heap, we need just O of n. So for this, using the bottom-up algorithm, a heap of a size n can be constructed with the fewer than 2n comparisons. Heap sort using the bottom-up approach. Heap sort is a sorting technique used to arrange the numbers in ascending or descending order user either max heap or min heap on whether the elements are arranged in ascending or descending order. Sorting technique can be easily implemented in two phases: heap creation, delete root item and insert in an appropriate sorting method. Sorting phase, items are arranged in ascending or descending order. Exchange the root item with the last element and decrement the size of the heap. Heap sort. Tracing the heap sort, initially using the function of bottom up heap, create the heap, exchange the a0 and the a of 6. The last element is sorted. Recreate the heap for remaining 6 elements. That is then sorted and recreate the heap for next 5 elements. Repeating this way, all the items are arranged in the ascending order. Analysis of heap will be like theta of n plus function 2 of f2 of n. And again then t to swap and recreate the heap. The relation between n and height is h equals to log n to the base 2, and relation to heap depends on the height of the tree. 52. This recreate the heap for n minus 1 elements to log n minus 1 to the base 2. And then total TE of T of n is given by the inequality T of n less than or equal to 2 log 1 of this theta of n plus theta of n log n to the base 2. Observe that while creating or recreating the heap, the number of comparisons required to move an item from parent position to the child position is given by first comparison is to find the largest child. Second comparison is to determine whether the parent should be exchanged with child node or not. Then create a heap in the top-down approach. Thank you for watching. Do like, share and subscribe to my channel.